dear friends! Today we will show you the new QRP-Labs Transceiver.
My son Ricardo welcomed you before because we are glad to introduce you to new QRP-Labs kit from Hans Summers. It is so small, so cheap, but so amazing. It has a lot of features like 200 Hz CW filter, 50 dB sideband cancellation, built-in signal generator and test equipment, and a iambic carrier already inside the firmware, and a lot of features we will go deeply to show you today. Thank you for watching this video, and excuse me for my not perfect spoken English, but it is not my native language. I'm Italian. Thank you for watching video. This is the kit package, very small, as you can see, 14 centimeters per 9 centimeters, less than 170 grams. Then go to unpackage it. Very well done package, very well protected. We have all parts over the table, and let me show you what we have. On this side we have all resistors, they are more than 50. Here I have 20 meters low pass filter kit with toroids, enameled wire and capacitor and pin just to put over the PCB. Let me remember you that at the moment of the order you can choose your preferred band between 80, 60, 40, 30, 20 like this, and 17 meters band. Here we have toroids. Then the 28-pin microcontroller ATmega328P with a relative socket for printed circuit board. Okay, you have to solder before this, then you can plug on the ATmega328. A BNC connector, a 5 kilo ohm logarithmic potentiometer, enameled wire for 1.5 meter, 2 push buttons, 6 pieces of BS170 MOSFET transistor, a 16 pins male header with a relative female 16-way pin socket, another male pin header, a lever micro switch that you can use like a vertical Morse key directly on a PCB, a 30 picofarad trimmer, then 100 kilo ohm trimmed potentiometer, two types of diodes, an MPS 2907 transistor, a rotary encoder with the shaft push button, two-way terminal block, then a 5 volts voltage regulator, two pieces of 3.5 millimeters stereo jack socket, two crystals, 20 and 27 MHz. 8 pieces of hexagonal nylon spacers with 12 screws. 6 8-pin LM4562 integrated circuit. 14-pin 74 ACT00 chip. The volume gain and rotary encoder knobs. Then ceramics capacitors and electrolytic capacitors. 3 multi-turn trimmer potentiometers. This is the PCB. Where you can find already soldered the only two components of the kit in SMD technology, surface mounted device. They are already soldered, so you can save a lot of work if you are not able to solder SMD, like me, for example. These two components are the famous synthesizer integrated circuit SI 5351A and the FST 3253. Then we have the LCD screen, two lines for 16 characters each one. So it seems to be alright. We have all parts we need to assembly. Hoping my son didn't take one of these parts to feed the neighbor's dog. Let's go to assembly. Before to begin the assembly, let me kindly suggest you to strictly follow the instructions made by QRP-Labs, made by Hans Summers. These instructions are very well done and will follow you step by step with checking parts and layout just to look where the parts must go. And you can find color pictures that really will help you to make a good soldering. And in the second sections you can find all instructions made in order to calibrate the device and setting up it. Don't worry, there are only 137 pages to read, but believe me, it will involve you more than a spy book. Let's begin with integrated circuit socket. all 6 integrated circuits LM4562. Now go to solder the IC3, that is a 14 pin integrated circuit. Now 100 nanofarad capacitors. All the 16 capacitors are on their right places. All their legs, as you can see, are bended outwards, so we are ready to solder. All 16 capacitors are soldered. It looks like I didn't make any mistake. The last famous words. This is the job done with all capacitors installed. 43 ceramic capacitors. Now let's go to install 4 diodes 1N4148. Okay, 4 diodes are on their places. Now we are going to install a Schottky diode, and it protects the radio against the reverse polarity. You can install a simple jumper wire in lieu of this Schottky diode, because the voltage drop for this Schottky diode is about 400 millivolt. So if you would like to have a little bit more radio frequency power output, you can avoid this and put a simple jumper wire, but be careful with the power supply polarity. And now the 2 crystals, 20 MHz and 27 MHz. Okay, the crystals are both at their places. Now we are ready to install 15 10 kilo ohm resistors. Let me check the value just to be sure. Okay, that's perfect. Here we are. All 15 10 kilo ohm resistors are at their places. But now, if you agree, just a moment for a coffee prepared by my wife. Italian coffee. Let me show you the printed circuit board with all 58 fixed value resistors soldered. Let's go to install the 100 kilo ohm trimmed potentiometer on position R37 here. This is made to set the LCD contrast. Now go to install 500 ohm multi-turn trimmer potentiometer. There are three multi-turn trimmer potentiometer, as you can see. Okay, so the three multi-turn trimmer potentiometers are at their own places. Now I will solder 200 microhenry inductors. That is fine. 107. Okay, this is not a very well done job. Let me a little bit bend position. Okay, I prefer it now. Now we are ready to solder 6 electrolytic capacitors, 10 microfarad each one. Remember, since they are electrolytic capacitors, they are polarized, so you must install with the correct orientation. The longest leg is positive and the shorter leg is negative. Okay, here we have all 6 electrolytic capacitors for 10 microfarad each one. 1, 2, 3, 4, 5, 6. Now we are ready to install another electrolytic capacitor, but this time it is bigger than usual, as you can see. It is a 220 microfarad capacitor, and ideally it has to be installed vertically, but the problem is that if we install vertically, there may be a contact with the LCD screen on the bottom side, so install it horizontally. Here you can look how I put this big electrolytic capacitor. Now we are going to install a 30 picofarad trimmed capacitor. It's done. Now it's the moment of transistor MPS 2907. slightly open the legs. Okay. Push slightly. Okay. Now I will go to install the remaining 6 transistors. They are BS170 transistor type. The position are these 1, 2, 3 on the top. These other 2 positions here. And the most important position is this, just under the volume knob, the gain knob. So it is very important that you push down the transistor as far as possible you can towards the printed circuit board, in order to avoid that the volume knob will touch the transistor and will not work properly. Now I will go to install a 6 pins header in order to connect a VR programmer to apply firmware updates in the future. Now you can install a 4-pin header from the low-pass filter kit bag. This is used to connect GPS module if required. Now we can install 3 pins for digital voltmeter and radio frequency power meter functions here. Now we are going to install 3 pins for another 3 test points for frequency, signal, clock 0 and clock 1 signal. Now the power connector here. Now 7805 voltage regulator, 5 volts here. And let me show you, this is the final job with a well-aligned voltage regulator, as you can see. Now I'm going to install pin headers for LCD module. That's fine, all 16 pins are soldered. They seem to be well aligned, as you can see.
Hello.
Now the hard work, probably. I begin with the wind and install the 5 toroids. L1, L2, L3, L4 and the biggest one named T1 here. the suggestion is to remove the enamel insulating paint that is coating the wire outside with a cutter or simply with the tip of a solder iron, so that you can check the continuity with a digital voltmeter. Let's go. The first toroid I'm going to make this time is the L4 according to the assembly manual, and for my bend of 20 meters I have to make 10 turns. Now I will try to remove the enamel with the solder tip. Probably there are different methods to achieve the goal. You can write in the comments below in order to show the community. Okay. So the value expected is 0.4 microhenry and the real value is 0.4445. That means 10% more than expected. Then let's go to solder the L4 toroid inductor on PCB. Okay, it seems to be very well aligned. Now it's the moment of L2 toroid that you can find in supplied low-pass filter kit bag. For 20 meters, the turns now are 17. Now I'm going to put an even space between turns, a little bit equal one to each other, like this. Then go to solder on PCB. So this is the situation after the soldering of L4 and L2 toroids. I'm sorry, but I was a little bit tired and I forgot to measure the value of the L2 toroid inductor. Now it's the moment of L1 and L3 inductors, depending from the bands we have chosen. For 20 meters band, the value of these inductors must be 0.77 microhenry. That means 16 turns for each one of two toroids. Now the expected value of L1 and L3 inductors is for 20 meters band 0.77 microhenry. Okay, 0.92 in lieu of 0.77 microhenry. Now the L3 toroid. Let's go to check continuity. Okay. Now the four toroids L1, 2, 3 and 4 are at their places. Now let's go to install the more complicated piece in all the kit. It is the transformer T1. This is a little bit tricky and complicated because it has four different windings on the same toroid. And for example, for 20 meters band, you have a primary winding of 3 turns, secondary 1, secondary 2 of 3 again turns each one, and the secondary 3 are made by 30 turns. Now that the T1 toroid is ready, after a lot of work really, with its 4 windings, it has 8 points where we have to put wire inside before to solder. Okay, this is the job done after the soldering of transformers T1. I jumped the video, as you can see, because I said some strange words and I have a reputation to defend. Now that we are finished the big work with the toroids, we are approaching the end of the assembly phase with a few components more. They are big components, so very simple to install. The last famous words. Now it's the time for two 3.5mm stereo connectors, one on the left for the earphones and the other one on the right for the paddle key. Now it's the moment of two push buttons, S2 and S3, S2 on the left and S3 on the right. If you want, you can find all the instructions you need in order to solder these two push buttons in a front panel, for example, if you put the kit inside a closed box. Okay, the job is done. A simple check for the buttons. Okay. Now the rotary encoder with the center axis push button, as you can hear. The position is this. Okay, it's fine. Now it's the moment of this micro switch that will work as a vertical strike key. Okay, the 3 holes seems to be very well soldered. A lot of soldering wire, but the job is well done. Let's go to install this gain control potentiometer, or volume knob if you prefer. We have to bend these 3 pins upwards 90 degrees in order to put these 3 pins in these 3 holes. Okay, now I'm installing the 4 12mm hexagonal spacers for LCD screen in order to keep the LCD screen detached from the PCB board. Okay, the 4 hexagonal spacers are at their places here. Go to install another 4 spacers, same length, 12mm hexagonal nylon spacers, just at the 4 corners of PCB in order to have fit to put your kit over your desk or your workbench or to fix inside an external enclosure. Okay, we have our 4 pillars. Now we are ready to install these 2 beautiful knobs. One over the potentiometer on the left for volume gain, and the other one over the rotary encoder. So then you have to unscrew the little screw here inside in order to open this hole completely. Okay, now we can install. Perfect. Then go to rotate the screw. Okay. Let me put this second one. Okay. Now I can screw here. Okay. That is good. Okay guys, so we are really approaching runway for landing. We have to install the 16 pins female connector in order to put the LCD screen over a printed circuit board. These 4 nylon headers are a little bit longer than would be ideal. Leave a small gap between 16 pin female header connector and the LCD module. The 4 nylon screws are okay. We are ready to solder these 16 pins. But before to proceed with soldering, I realized that I forgot to install the radio frequency output BNC connector. And luckily now I have the space here without dismount or disassembly anything else. Okay, after the aborted landing because I forgot to install radio frequency BNC connector that now is correctly installed, I really can go ahead to finish the job soldering the 16 pins of LCD module. The job is done. I don't believe it, but I have finished the job. And now you can throw the tomatoes on me. I hope you like it. I will use this AC/DC adapter with an output of 12 volt at 2 ampere. That is enough. Okay, all the work is done. Before to proceed to power on the device, I preferred to upload the new firmware 1.00B, like Bravo. I used a USB ASP small device with I have 10 pins here, but it's very simple to use some cables, DuPont cables, to change from 10 pins to our 6 pins here on PCB. You have a ground pin on top left, reset pin on top right, then master out slave in, serial clock, and DC in bottom left, and in bottom right master in, slave out. Okay, I don't believe it, but I'm really ready to power on now. So the first thing we have to do is to adjust the trimmer potentiometer here on top left to adjust the LCD backlight until it is comfortable read the display for us. I'm rotating counterclockwise. Okay, little bit clockwise and again counterclockwise, very sensitive. That is the best for me. I choose the 20 meters band for me, that's fine, and confirm pressing the left push button here. Okay. There are 4 more adjustments which now need to be made for complete the alignment procedure. These are the band pass trimmer capacitor picking here on the right through this screw. Then the IQ amplitude balance with the R27 resistor here, even in this case by this screw, for IQ amplitude balance. Then these last 2 variable resistors for audio phase shift adjustment, the R17 on the right and the R24 on the left. The alignment tools built in the radio, in the kit, consist of a signal generator which injects a signal into the radio frequency front end, and a digital signal processing which adds 240 Hz digital filter to the existing 200 Hz analog filter, and calculates the amplitude of the signal detected in that bandwidth. I remember you to unplug the antenna during the alignment of the radio. So here the antenna must be unplugged. First, adjust the bandpass trimmer capacitor C1 on the right. To do this, give one long press on the left button, one long press, okay, to show preset here. Then turn the rotary encoder here until you see the menu alignment. Okay, alignment. Now we press again the left button to enter inside the alignment menu. Okay. And now turn the rotary encoder until we see peak BPF, peak bandpass filter. Okay, this is. Then press select, it means press the left button, it is a select button. When we are on 8.7 menu, we can plug a stereo headphone here and see and hear 700 Hz tone, but now I unplug because it is not important now. Then we have to reach the maximum value of this peak. Let me tell you that this variable value bar is auto scaling bar. Okay, so it means that when I reach the maximum, it comes to next step from a value I'm explaining now to you. Let's go to lower number, that is 5 in my case. Okay, 5. What does it mean? This means that every single bar, vertical bar here, has a value of 2 power 5. It means 32. Okay, so when I little bit rotating clockwise this screw, you can see that the bar is increasing in the value. Okay, now it is increasing, and when it reaches the maximum, it comes to be lower, but with an increase of one number here, from 5 to 6. Let me show you now. Look at that. Okay, I have 6. What does it mean? This means that now the single value of a single vertical bar is 2 power 6, not more 2 power 5 like before, but 2 power 6. It means that every single bar has a value of 64. Now I will increase, I will rotate more clockwise. The total bar is increasing. Okay, then when reach the maximum, the number on top right comes from 6 to 7. Wow. Okay, it means that now a single vertical bar has a value of 2 power 7. Okay, that means 128, and so on. When I continue to rotate, eight. Okay, we are reaching the maximum, because now a single value is 2 power 8. It means 256 value for each bar, for all times of how many bar you can see here. So I will reach the maximum, rotating clockwise. Okay, it seems not to would like to go over this number of bar. So, okay, I comes to go counterclockwise, then again clockwise, then again counterclockwise. Okay, this is the maximum in my case. Okay. When I leave off the screwdriver, it may change a couple of bars. So, a single bar, a value of a single vertical bar is a 2 power 8. That means 256. Okay? So, the total value is very simple to calculate, because we have 43 vertical bars. Okay, so 256 times 43, and the total is 11,008. This is the total value of the bandpass frequency peak in my case. Okay, go ahead to adjust the IQ balance. This is on the menu 8.8 IQ balance, and you can see in the top right the volume level. This is the best value for volume before to begin to adjust the IQ balance value throughout the R27 variable resistor here. Then let's go to reach the minimum. In this case, the minimum again, because we would like to minimize the unwanted sideband level. That is the purpose of this adjustment. Let me a little bit rotate clockwise. Okay, it is increasing, not good. Go to counterclockwise. Again, reach the more value. 9 volt, okay. Okay, we try to go clockwise. Oh, okay. This is the minimum for me. Okay. And the IQ balance has been done. Now we can go to adjust of 90 degrees audio phase shift, rotating clockwise of one click for rotary encoder. So phase low and phase high. Okay. These are menu voices 8.9 for phase low and 8.10 for phase height. We must adjust it for a minimum signal for both phase low and phase high. The two variable resistors involved in this adjustment are here. They are side by side, R24 and R17, R24 on the left and R17 on the right, phase low and phase high. For phase low, we are going to reach the minimum, counterclockwise, not good direction. No. Okay, this is the minimum for me. Then go to phase high. Okay. And that is good value for me. Now it is important, you know, that it is necessary to go back and forth between the three menu items for minimum unwanted sideband. These three items are IQ balance, phase low for adjusting the low audio phase shift, and the phase high to adjust the high audio phase shift. So why you have to go back and forth between these menu items? Because these adjustments influence each other. Because when you set it up the first one, probably setting the second and the third may have influenced the first one value. So please come back for your convenience, just work some minutes over these three values and be sure you have effectively reached the minimum value of all three values. Now I will show you all the operator controls. We have a volume knob on the left, of course. okay? You can set till to have a comfortable volume level. Then on the center you have the rotary encoder that we call a center button. Then you have left and right buttons too. Each of the buttons may be pressed once, twice, or for a long hold. So this means that 3 buttons may have 3 functions each one. During the normal operation, I have the display in this mode where I can look at VFOA. Then pressing the right button once, I can jump from 3 kinds of configuration: VFOA, VFOB, and split mode with both VFO frequency displayed. What does it mean? It means that when I have only VFOA, I receive and transmit on that frequency. When I have only the VFOB frequency, I receive and transmit on this frequency. But when I have both frequencies, I will receive on the first A and transmit on the second one, B. Okay, begin with the VFO operations by center rotary encoder. I can change the position of the underline cursor here. It can go step by step in different positions pressing the center button. Okay, now it is in the position of 10 Hz, now 1 kHz, now under the comma, now under 100 Hz, and then repeating, okay, kilohertz, under comma, 100 Hz, 10 Hz. When you are under a number, you can change that number. So here you can go up and down in the frequency in steps of 1 kilohertz. Here you can go in a step of 100 Hz, then here in the step of 10 Hz. What happens when you put the underline cursor under the comma? It means that the tuning rate is 500 Hz, as you can see. The function of the keys are a select function for the left key and the exit function for the right key. So when you push the left button, you go to select, step by step, go deeply in the menu voices. Then when you have done all changes, or you want, for example, to cancel a new setup you made for mistake, you can go easily outside pushing this right button, exit button. This is more or less like the ESC key of your keyboard. If you push once the left button, you can easily reach the carrier speed configuration, showed in words per minute, in this case 10, for me is good. You can go throughout all the speed you want, from 1 up to, I don't know, probably more than 100. Let me check just for curiosity. 99. Okay, if you go outside the menu, for example 80, okay, if you are like a Superman and set to 80, go to exit, and when you push again the left select button, you will find the last value you set it up here, 8. So select and exit. Let me come to my humble value of 10 words per minute, then come to exit from the menu and go ahead. Now, if you double click left button, you will go in receiver incremental tuning setup that allows the receive frequency to be adjusted, while the transmit frequency, I remember you, remains the same, and the transmit frequency is that one reported beside the VFO-A symbol, the letter A. So I can change the RIT, receiver incremental tuning, so that my receiver will receive on frequency of 40 MHz, 18 kHz plus 5 kHz. Okay, I can go just to the other steps of the frequency, but this time I have to push the center button, then in the meanwhile it is pushed down, I have to rotate the knob, the center knob, okay? For example, on the number of 100 Hz, I leave the pushing, then I can change this. If I would like to change 10 by 10 Hz, I have to push again, rotate on the clockwise, then release the button, the center button, and go to change this. For the last Hertz number, again, push down the center button, then clockwise again, then release the button, and I can change this last number for receiver incremental tuning. If I would like to receive at plus or minus 1 kHz, I can set just now. Let me go here on the left, put this to 0, again on the left, 0, again on the left, and minus 1. Okay? If I put the cursor under comma, okay, I will go in steps of 500 Hz, half a kilohertz. So, when I reached the value I desire, for example, minus 1 kilohertz, I push again the left button, then I can go to operate. Okay? Of course, the frequency now is that one displayed on top. So if I have in 14.025 and I go to transmit, this means that I will transmit on 25 kHz, but I will receive on 24 kHz, because it is 25 minus 1 of the receiver incremental tuning set up before. If I would like to cancel the RIT value, I have to go again in RIT mode, clicking twice on the left button. Okay, then I have to push the right button to cancel. Okay, it is cancelled now. I have no RIT displayed here. That means that I will receive and transmit on this frequency. To enter in the main menu system, we have to give a single long press to the left button, the select button. Long press. Okay, then I'm in the menu. The menu is organized into 9 groups as the follows. 1 preset, second is messages, VFO, carrier, decoder, beacon, other, alignment, test equipment, and save settings. And you can use the rotary encoder to scroll back and forth between these 9 sub-menu group listed before. If you would like to enter inside one of these items, you have to push again the left button here. For example, come to preset. Okay. if you would like to return to the main operating mode, it means you would like to exit from the menu selected, you have to push the exit button, the escape button here. So you are again in the 9 groups. Okay? Would like, for example, to enter in menu 4, press select and change the different voices, then come back like this on the right escape button, exit button. If you push again this button, you come back on VA4 and you are able to transmit. So begin with the first menu. So go inside the menu items with a long press of the left button. Okay, then choose the first one, preset, and click once on the left. Okay. There are here, it is very simple to navigate inside because we have the paragraph 1.1, 1.2 and so on, even in the other items 2.1, 2.3 and so on, so that you know every time where you are. Okay. In the case of the first item, there are 16 preset frequencies, named by preset 1 to preset 16, and come again 16 to 1 with rotary encoder. What these preset frequencies are? These are simply your preferred frequency that you would like to store here. In order to be recalled after. So for example, my preferred frequency is that for QRP, that is 14 megahertz and 60 kilohertz, and I would like to set it like in the first position. So I will go in preset 1, then push the left button. Then if you would like to change only 60 here, I have to push again once to jump the cursor until it is in the position useful to be changed by rotary encoder. In this case, jump, jump, jump here and put 6, jump again on the right and come counterclockwise to 0. Then I push the exit button and I have my preset 1 on my preferred frequency for QRP. Let me show you how to check it is stored, saved in the EEPROM memory. If I go in the other preset position and came back to 1, I will find again 060. And if I exit from the menu, again exit, and I come again inside with a long press, preset, short press, I will find here. That's fine. So, if I have saved the preset frequencies in the preset menu, for example 14060 in preset 1, 14061 in preset 2, 14062 in preset 3, just for example, I can immediately recall these frequencies when I am in the normal operation mode. Just double click on the right button. Okay, it will show me all the frequency memorized in the preset values. This is the number 1, 14060, as you remember, number 2, 14061, number 3, 14062, and so on. So I can go through all the 16 frequency, then come back to the first one. What I can do with these frequencies, as these characters suggest us, with the left button I can save the current value in the position 1, or with the right button I can load it. So if I push the right button, I can load to the VFO. Look at this. Okay, I have loaded. Okay, but if I move and call again the number 1, I can save 57 in the 1 position. Okay, and if I call it, I have now 57 and not more 60. Then if I would like to exit from this frequency recalling without make any choose, save or load, I can push the center button and it will exit. The second group of the menu is messages. I can go inside with a single left click. Then I find 14 configuration items in this menu that are 12 messages from message 1 to message 12, then interval and repeats. These 12 messages you can set are messages that you can use in order to transmit in automatic mode, like a beacon. Message from 1 to 4th have 100 characters text stored inside, while messages from 5 to 12 have 50 characters text stored. Let me go inside message 1 with the single left click. Okay, then here I can set CQ the Italy Zulu 7 Victor Hotel Foxtrot, for example. I use the rotary encoder to change letters, some special characters, and after I have numbers and then letters. So I go to C, then left click, and I go to Q. Let me suggest you that you can go counterclockwise in order to find immediately the letters, beginning from the Z and going forward to the A. So CQ, PQ, okay, left click, then I have the default space, so if I again left click, I will leave a space inside, very simple. CQ, there, D, then E, then space, left click again, and then Italy Zulu 7. So CQ, the Italy Zulu 7 Victor Hotel Foxtrot AR, then I exit and it will be saved. Very simple. If I go to message 2 and come back to message 1, I will find the message stored just a second before. So I have 12 messages I can set up for my purposes. Then 13 and 14 are very simple. The interval is a number parameter that specifies the interval between repeated transmission of a stored message. In seconds, this is important. So if I put 10 here, left click, choose, okay, 9, 10, or to be polite, probably 30 seconds is better. Okay, exit, come back, okay, we'll find 30. It means that when my message is ended, the system will be waiting for 30 seconds before to begin to transmit it again. And last 2.14, how many times that message has to be repeated. So the repeats parameter exactly specify how many times the message transmission will be repeated. And you can choose left click again from 1, 2, 3 up to probably 99. And then after 99 there is an option to transmit ad infinitum. That means in this case that the message transmission continues indefinitely, forever. Like in this case, I come back, and if I would like to take a look, message 1 again is the message we have stored before. And we can exit from this second group. So, when I have finished to store the messages inside the memory, how may I call back them in order to transmit them on the air? When I am in the VFO operation mode, here, I can press the center button with a single long press. So, all the messages will be recalled back, like CQ, the Italy Zulu 7, Victor Hotel Fox, or Spaghetti Mandolino Berlusconi, just for fun. When I have chosen the message I would like to transmit on the air, I have 3 chances corresponding for each button. If I push the center button, the message displayed will be sent once. If I push the left button, the message will be sent repeatedly according with the repeat menu I set it up before. But if for any mistake I would like to come back, I change idea, I don't want to transmit anything, I can use the ESC button on the right to come back on VFO operation. Again, long press on the center button, then choose message, and then I can send it automatically just once with the center button or repeatedly with the left button. Let me just send once. And it works. Fine, very fine. The message has been transmitted once. The menu number 3 is for VFO operations, and these parameters inside will affect the next startup configuration. You can change parameters here in order to find them at the next startup. 3.1 is the VFO mode. You can select between A, B and split in order to find here A, B or split at the next startup. So you can select inside 3.1. For me is good to find A. Then VFO A is the frequency of the first VFO. VFO B is the frequency for the second VFO. Tune rate is the tune we would like to have for the main knob here, the rotary encoder in the center. We can choose between 100 Hz, 10 Hz, 1 kHz and 500 Hz. Let me choose for me, for example, 100 Hz, that is good. Receiver incremental tuning. I can choose the value I would like to find even this at the next startup. I can choose all frequency I would like to have to 1000 Hz and 100 and so on, up to the last number to set up the last Hertz one by one. For me in this case is 0 because I would like not to use RIT function at next startup. 3.6 receiver incremental tuning rate. I can choose between 1 Hz, 1 kHz, 500 Hz and 100 Hz, 10 Hz. For me it's good 100 Hz. Then let me remember you that this first 6 parameters from 3.1 to 3.6 included. You can change with the first procedure coming here in this menu, or if you prefer, in the meanwhile you are operating with your device, you can go to save settings, then save, and all the parameters already selected now in this moment will be saved inside the menu number 3, like a picture in this moment. Okay, for example, if I have a VFO number B on this frequency and I go to save settings, these parameters will be saved inside menu number 3. So the procedure to save data for next power up are two. The first one is the longest and consists of coming here inside 3.1 to 3.9 menu, or if I prefer, the first 6 up to 3.6 may be saved faster using the function save settings. CW mode, CW normal or CW-R if you would like to change the sideband where the CW signal is received, because there may be some occasions where operation in the other sideband is desired in the lower sideband, for example to exclude an interfering signal by a nearby station or something like this. So if you change this, it really change in the memory inside. 3.8 CW offset. What does it mean, this 700 Hz value here? This is the difference during the receive mode between the frequency really received and my local oscillator. For example, if I have a signal on 14 MHz and 60 kHz, like my preferred frequency of QRP, and I will go with my knob on this frequency and I hear a signal with an audio tone of 700 Hz because I like and I choose it 700 Hz, really I have my local oscillator that is oscillating at 14 MHz, 59 kHz and 300 Hz, because the difference from the frequency I can look on the display and the frequency of my local oscillator creates the so-called bit frequency oscillation, that in this case is exactly 700 Hz. I can change this offset here, but let me warn you that since this device has a 200 Hz analog audio filter, it means that if I go extremely high, more than 100 Hz more than 800 or less than 600, I can lost the signal. I cannot hear it more because it will result highly attenuated. Probably if someone of you is an expert and would like to experiment some different solution, you can go more than 800 or less than 600, but you have to change something in the hardware because to modify this value in this menu. Because again, the hardware is designed to have the filter circuit, the 200 Hz audio analog filter circuit, centered on more or less 700 Hz. 3.9 band. This is of course the chosen band configuration of your radio that has been asked you in the first power up. Of course, you must not change this setting, or if you have an idea to unsolder the components soldered for the 20 meters band, okay, you can unsolder this, change this with the other components for another band, for example 40 meter, then come here in 3.9 menu and change this parameter from 20 to the 40 meters band. Now the fourth group here that contains parameters relating to the CW keyer. Keyer mode. You can choose between straight if you would like to use the onboard micro switch like a straight key, or if you have your own vertical key and put the 3.5 millimeter socket on the right here. I remember you that you can use this right socket either for vertical keys than paddle keys. Or you can choose Iambic A, Iambic B, Ultimatic that are three modes to use paddles. So in this case I choose vertical key, select by single press on left button, then I have selected straight key. 4.2 keyer speed, I can change it with a left click, then rotate knob, then right click to exit from menu twice. Or if you would like to go faster, you can use the previous showed function, save settings. This function is very useful to immediately and faster save 7 parameters from 3.1 to 3.6 and exactly the 4.2 keyer speed. This is 12. Or if I prefer, I can go to 18. Okay. 4.3, the keyer swap menu allows us to swap dot and dash if you prefer have the paddle key reversed. 4.4, keyer weight allows you to change the ordinary Morse dit and dash durations that have normally 1:3 ratio. 4.5 auto space. Auto space is another parameter that allows you to force the auto spacing between every CW characters. In off position you can have the space between characters determined by your own time, but if you select on, that is the second option, you will force the device to wait a time equivalent to 3 dits lengths after every characters. 4.6 QS key, famous parameter. You can set full QS key or semi-QSK. Full QSK means that after the very small delay time for the radio frequency envelope shaping, the transmit receive switch set the device to receive. So it means immediately when you finish to key down and put key up in full QSK, you immediately hear the frequency for signals. It means that inside your transmission, for example CQ, between C and Q, you can hear the activity on the frequency if there is another one operator or more than one that are sending signals. Or you can choose semi QSK. It means that after key up, there will be a delay before the device switch itself to receive mode. This may be useful sometimes to avoid the distractions of hearing the band between your dits and dashes. 4.7 practice, default value is off, but you can set on, that is the only another choose. If you want to practice sending CW and look at the characters appearing here on LCD. So if you would like to learn and to practice, you set on, and the device will work exactly normally, but with the difference that it never sends any radio frequency outside to antenna. 4.8 side tone frequency, default value 700 Hz. That is the frequency of the tone you hear when your key is down. Don't make a confusion with the previous 3.8 value that is CW offset, because that is for receiver, okay, for the tone you are receiving for a transmission made by another operator. But this is in 4.8 is the tone you will hear when your key is down. Of course, I kindly suggest you to keep the same frequency, but for side tone frequency in this menu, then in 3.8 CW offset, in order to learn to recognize the 700 signal and center it when you are moving the dial to center the signal received. 4.9 side tone volume is a parameter to reduce the volume of the side tone audio. The default value is 99, but you can select a lower value, like me. I have found 50 is enough to hear a comfortable audio signal. 5. Decoder menu. It has 6 voices. Noise blanker, speed average and amplitude average are 3 values related to CW decoding, and it concerns mathematical theory. If you would like to go deeply, you can find information in assembly instruction manual. Enable RX. It allows you to choose to have CW decoder in receiving mode, off or on. Then, if you would like to have in transmit mode, if you would like to read your own letters made during your key down. Enable edit enables CW decoding while editing. When the option is on. Anything you key during the editing of configuration parameters will edit that parameter. This is a useful feature that makes it very easy to enter frequencies or stored messages, for example. Menu number 6, beacon. That is a very value added function to this beautiful device. As for previous experience of QRP-Labs products, you can go inside and choose if you would like to have a beacon, off or on, of course. Then 6.2 mode of beacon. You have two possible modes, WSPR and CW. If you choose WSPR, the device will use the next parameters I will show you. 6.3, the frequency, transmitting frequency of the beacon, then 6.4 frame and 6.5 start. What these frame and start values are? These are for only WSPR beacon mode. If I choose frame 10 minutes and start 4 minutes, it means that the first transmission will start at 10:04 minutes and next transmissions will start 10:14, 10:24, 10:34, 10:44 and 10:54 every 10 minutes. Exactly what I set it up in 6.4 menu frame here. Then 6.6 WSPR call, that is simply your call sign. Then WSPR locator, in my case my town is in JN80 Maidenet locator, and WSPR power, in this case 33, corresponds to 2 watts. Then here set time, you can set manually. Be careful to set the time in order to have not more than 1 second the difference between real time and your time here. Let me tell you that the time and WSPR locator may be automatically set up if you have the GPS module connected here. Menu number 7, other. You have double click speed in milliseconds. It defines the time within the system will check if you intend to single press or long press or double press the push buttons left and right, and you can change it. Battery show on, it means that you can look this symbol here on the right. Then battery full, 13.8 volt. It means that at this value I can have the battery symbol full. Then battery step, this is the step, again specified in millivolts for each bar or horizontal bar of the battery icon. The cursor style, maybe blink or underline. Show as meter on, in this case there is a chance to show an S meter on the top right of the display. S meter step 7.7. The S meter has 12 bar maximum. Each bar of the S meter equates to the specified S meter step, here number, on the amplitude measurement scale. So the value indicated here, I found as default, means the value of a singular vertical bar of 12 bars. So if I set 100, it means that all 12 bars of the S-meter make a total measurement of 1200. That is 100 times 12. 7.8 factory reset. This item is simply used to keep a factory reset that returns your radio to the supplied default factory configuration. Then everything is erased and set back to the default parameter, like the device has been powered on the first time. We are to the menu 8, alignment. Let me tell you again that this device is a little bit magic because use the built-in signal generator, that is the same SI 5351A, that has 3 signal outputs, and using the signal generator output to inject a test signal back into the receiver's front end. This is a very simple, a very smart idea from the designer Hans Summers. And if you use correctly these alignment tools, it is possible to adjust and align the receiver without the external test equipment that sometimes are not so cheap. 8.1 is align frequency. This is the frequency which the alignment tools operate. Of course, you have to choose a frequency that is a little bit in the middle of the frequency you would intend to use. 8.2 IQ balancing frequency. This is the audio frequency at which the IQ balancing adjustment is performed, and by default it is set to 700 Hz. That is the center of the audio filter and what is usually used for CW offset frequency. Then go to 8.3 phase low frequency and phase high frequency. As you can see, the phase low is 600 and phase high is 800. It means phase low 100 down and phase high 100 up. So the phase low is the audio frequency at which the low audio frequency 90-degree phase shift is performed. Then at the same time, the phase height is the audio frequency at which the high audio frequency 90 degrees phase shift is performed. 8.5 reference frequency is very extremely important because this is the frequency for the synthesizer chip, the heart of our transmitter. This is. If you set this to the actual oscillation frequency of the 27 MHz crystal that you have here, then the output frequency of the radio will be accurate. But as you know, the 27 MHz crystals are not made in a perfect world, so probably they oscillate between 3 to 5 kilohertz up. You can set it manually if you have a radio receiver with a very narrow filter. I used my ICOM 7410 that has a CW filter of 50 Hz. Then I set it manually. But again, if you have a GPS receiver module, you can use the PPS, pulse per second signal, in order to calibrate this. The system will use the first 4 pulses to set the frequency, because to have a $10 GPS module is exactly the same to have an atomic clock in your house without the risk to an explosion. But again, you can set it manually, go through the numbers, you can set it manually until you will check with the oscilloscope or your big rig radio receiver that the transmit frequency is exactly where you intended to be. 8.6 system frequency. That is the second oscillator at 20 MHz that is used for the microcontroller clock 80 MHz 328P that allows frequency clock up to 20 MHz. So in this kit, Summers decided to use the maximum frequency, so the maximum speed for the 80 MHz 328 microcontroller. 8.7, then 8.8 IQ balance and 8.9 phase low and 8.10 phase high. I already explained you deeply in the first phase after the power on when we aligned the device. 8.11 and 12 are made in order to allow the GPS calibration. 8.13 GPS data when a GPS receiver is connected here on the right pins. Of course, plus 5 volts, negative ground, and data, serial data pin and PPS pin are connected. Then you can click the left button and you can look the data from display. Okay, I am outside balcony where it is better to receive a GPS signal. Then I'm ready to power on device. Device is powered on. As you can see, a red light for GPS module is on. Then we are waiting for green light flashing. That means PPS signal is coming. Let me wait a little bit more. And in the meanwhile, I can show you that in the menu of beacon, number 6, the 6.9 set time, the clock is not yet set up. Okay, Houston, we have signal. Then comes to a menu, number 8, alignment. Then go to GPS data. Okay, we have 6 satellites tracked, T for tracked, and the average signal strength for these 6 satellites is 35. Then go to alignment menu, 8.11, calibration reference oscillator, then left click and calibration begins. Look numbers, they are changing, then done. Okay, 52 as last numbers. If I come again, just for curiosity, we had 52. Come again to calibrate and look at numbers. 58, only 6 Hertz difference. So again, third time, 52, 58, and now 58 again, and fourth and last time for me, just for curiosity again, 52 and 58 twice, 58 again, so probably the right value is exactly 58. Then at same procedure we can go 8.12 calibration system oscillator for the 20 MHz, and it has begun. Okay, 358 again, 8.12 again, left click, we had 58, and now 59, only 1 Hz. Try the third time, just again for curiosity, select, and 59. Then go to GPS data. Okay, now we have GPS data accepted. So if I come back to beacon menu and look at the clock, I will find it set up. Let me go. Beacon. Okay. 7:58 Greenwich Mean Time. Here we are 9:58 in Italy, local time. And finally I can describe to you the last menu, number 9, test equipment. That is a very new tool for small cheap transceiver you can find on the market, and it is very helpful because it helps you to test your device, to calibrate initially, to align it, or in the future, I hope it will not happen to anyone, you can use it to fix some bugs on your device. And you don't need any external expensive device like oscilloscope or some other else like big receiver with a small CW filter in order to check what is the frequency output. You have your built-in tool package already inside. Controlled by microcontroller, signal generator, and inside the firmware made by Hans Summers, just to give you an added value for free, because we already have the 80MEGA328 microcontroller. It has the capabilities to make you the chance to have this built-in check test equipment. So why don't use it? And Hans Summers give us this chance, made a very fine firmware inside that include these test equipments that I will show you now. So let me go inside the first submenu, 9.1, voltage. What is this voltage? Let me show you this diagram. We have these 3 pins on the left, where is my tip of the pen, that are plus V output, radio frequency input, digital voltmeter input. The first one on the top is the voltage that we have after the Schottky diode, that is there in order to protect the device against the inverted polarity. But as you know, the Schottky diode asks a payment of about 300 or a little bit more millivolt in voltage drop. So since I have my DC in of about 12.25 volt, I read 11.93 because for the voltage drop in Schottky diode. You can join this volt output pin to digital voltmeter input here. So join the first one on top with the third bottom here, then you can read this voltage. Or you can connect another device if you would like to use this like a digital voltmeter. let me tell you, you don't look any joint here because I made it under the PC board. The measurable voltage comes from 0 up to 20 volt. Then 9.2 radio frequency power. This is on the schematic, the pin in the middle, the second here, that you can use like an input from external radio frequency you would like to measure the power output. It can measure power range from 0 up to maximum of 5 watts. The power measurement circuit inside uses a simple diode detector, so there are non-linearities in the diode function. So you have to remember that this measurement is not highly accurate, but it can help sometimes to resolve our problems. The only warning is to don't use the same measurement together, digital voltmeter input and radio frequency input. Don't use together at the same time because they use the same pin on the 80 mega 328 microcontroller. In fact, as you can see, I look at 1.91 watt here, but I'm not measuring any radio frequency in this moment. It shows this because I have connected the voltage here. So this is a fake value. I would disconnect the voltage input, then be free to use the radio frequency input. 9.3 audio channel 1, it displays a raw amplitude number calculated by mathematical algorithm from audio channel 1. The audio channel 1, I remember, is connected to the output of the audio amplifier, so this value is strictly connected with the gain knob, the volume knob here, as I can show you. Okay, more the volume, more the value. Then audio channel 2 displays the raw amplitude number calculated again by mathematical algorithm for the second channel that is connected to the output of the phase nulling circuit. You can find all deep information on the manual, but this is not related to gain knob. 9.5 we can find frequency counter, and again coming on the this schematic here, this is the pin you can use for frequency counter input. It is exactly here. I don't know if you can look it. Let me show better. Okay, this is the pin. Okay, I can connect here any source of radio frequency and it will measure for us. 9.6 signal generator frequency. It is simple, the setup for the frequency you would like to have for use this tool, this device, like a signal generator. The output frequency range is from 3.5 kHz up to 200 MHz, and this is for data sheet, but probably you can go up to 300 MHz. This is made by the magnific synthesizer SI5351A here. the output waveform, I just say you that is a normal square wave with an amplitude of about 3.5 volt peak to peak. Please note that this signal comes out from these two pins, clock 0 and clock 1 outputs, and are operated in a quadrature with a 90-degree phase offset. Before to contact some operators over the world, let me begin to check if my signal is coming out normally, checking by the web on one of the several web software defined radio that we can find on internet. In this case, that one put by University of Twente in Netherlands. Then finally we are on the air and we can try to have some QSO. Let's go! And now let me try to send a WSPR session, Wake Signal Propagation Reporter. I will wait to synchronize the time, because I am inside, I have no chance to use GPS signal, so this is the time from my smartphone. Let me keep the right space to show you. Okay. Then I can move the last number for minutes. I put on 7 because I'm expected to have 7. Then 9, 2 times. Okay. Then let's wait to start next session at even minute, so 6 p.m. and 38 minutes Italian local time. Then I will go on the web to show where my signal has been received and decoded. Okay, it has begun. Okay, it has been stopped. Let me have the chance to wait for the second session, so just to be sure to have a little bit more chance to be received around the world, I hope, or at least in Europe, or at least in Italy. Okay, second session has ended. Let me go to look at where my signal has arrived. So we are on wsprnet.org. Let me go on the database just to show this is the actual last activity. Specify query parameters. So my call, Italy Zulu 7 Victor Hotel Foxtrot, last hour is good, and on the band of the 20 meters. Then update, and as I can see, the first session 16:38 Greenwich Mean Time, and the second session my signal has been received from probably 10 stations. Then I go on the top right, click on map, and I set the filter here 20 meters band only. My call sign will be filtered, then last 30 minutes period, and this is the result. These are the stations received my 2 sessions of WSPR. I'm here, and I has been received in France, Germany, Belgium, up to Sweden. Very good result for a couple of sessions.